I want to go ahead and solve the practice exam that I passed out on Thursday and Friday. Uh, I will change the test dates in PowerSchool to reflect the day that we actually have the exam. And for C period, that's going to be Wednesday, and for E and F period, that's going to be Thursday. Um, so for C period, again, Wednesday the 13th, and for E and H period, Thursday the 14th, in time for the end of quarter grades. So let's just begin. Notice that I've got the sections labeled. And one of the things that I pointed out in class that I had you write down is that when we are dealing with one object, we will use the impulse momentum theorem when we have impulse momentum problems. And when we have two objects and we're in the impulse momentum section, that will be the conservation of momentum principle. So here, we have a 0.15 kilogram baseball thrown from rest. We're given a release speed, and we want to calculate the impulse. So this is something that will happen a lot in impulse momentum problems, where we have impulse defined as force times time. It's a force acting over a time. And the change in momentum is the final momentum minus the initial momentum. And what'll happen is because these two quantities are equivalent, meaning that an impulse acting on an object gives rise to a change in its momentum, we can actually calculate the impulse acting on an object based on its change in momentum, which is exactly the case in A. So we have M. It is thrown from rest, which implies that U equals 0. And we're given a final speed or velocity, v. So to calculate the impulse, we're going to actually calculate the change in momentum. So that'll be mv minus mu, which will be 0.15 times 36 minus 0.15 times 0. And that will give us a change in momentum equal to 5.4 Newton seconds. Now, we want to calculate the force on the ball. Now we do revert to the definition of impulse as a force acting over time. So that's going to be 5.4 equals F times 1.2, so that when we actually isolate F, we're going to get 4.5 newtons worth of force. Next, the baseball moves towards a bat that hits it and sends it flying back at 40 meters per second. So the point I want to make here is back means negative. And so let's calculate the impulse, but very carefully. Once again, it will be mv minus mu, since all we have is the final velocity. The other point we want to make is, since the ball is going towards the bat, I should have been clearer that this was happening at the 36 meters per second we calculated above. Putting all these facts together, the impulse is going to be 0.15, which is the mass of the ball, times, let's be careful, it's going back at 40 meters per second, minus 0.15 times the original 36 that it came in at. So when we actually calculate this number out, we're going to get an impulse of negative 11.4 Newton seconds. Let's get the force on this from the impulse formula, which we can do right here. So J equals, J equals F times T. So we have negative 11.4 equals the force times our time of 0.002 2 seconds. When we isolate the force in that case, we're going to actually get negative 5,700 newtons of force. That's actually quite reasonable for a baseball. That is a couple of tons of force, which actually is realistic force for a bat to be hitting a baseball with. So that is the first page. We're going to move into some multiple choice in the next page, and then from there we'll move into energy.